Okay, the last lesson that we just get through doing, we were talking about Pythagorean theorem. And Pythagorean theorem, as you recall, is just this simple formula right here of a squared plus b squared equals c squared. What we're going to do now is we're going to use Pythagorean's theorem right here, and we're going to find the distance between 2 points on a graph. And what you got to understand is you can have 2 points plotted, similar to this black point right here and that black point. The distance that we're trying to find is going to be the red line right here. It's not curved, it's straight. So that distance right there between the 2 points is actually the value of c, okay? Because what's actually created every single time that I set these things up is I'm going to, again, I will create a right angle right here every time, okay? So the value of c is going to actually be the distance in between those 2 points. We're going to find a horizontal change of distance and a vertical change of distance right here to plug into our formula, so that we can go from there, okay? So without any further ado, let me hit this right here, and we are going to set up our graph so that we can go about solving this bad boy, all right? So the first thing that we have is, let's go ahead and make my x and y axis. So I'll set it up over there. So there goes the x-axis, and here comes the y-axis. And now let's go ahead and let's plot 2 points. And the 2 points that we're going to plot right here are going to be the points -2 and -2. And the other point that we have is going to be 5, 3. Okay, the first thing that we're going to do is we're actually going to plot the points on the graph. And then we're going to set up some lines and some distances, okay? So the first one here is -2, -2. So here's 0, 0. So I go 2 to the left and 2 down. And there's my first point right there on the graph. The second one is 5, 3. So now it becomes 1, 2, 3, 4, 5, 1, 2, 3. And there's that point right there, okay? Now again, what we're actually trying to find, we are actually trying to find the distance in between these 2 points, which is going to be a straight line that goes just like that right there, okay? Also, what you can identify right here, I hope very quickly, is the fact that we're going to create a right triangle on the graph. Now, how's that going to work? If I draw a horizontal line that shoots across like that right there, and then I bring a vertical line coming from this line right here, where they intersect right there, that's going to create the right angle for me, okay? Now all I have to do is count the spaces on the graph and create my right triangle and go. So in this case right here, what do we end up with? The distance is 1, 2, 3, 4, 5, 6, 7. So that distance right there is actually 7. Make this a little bit bigger. It's actually 7. This distance is actually 1, 2, 3, 4, 5. So there's my right triangle, man. And the 2 legs that I have are actually 5 and 7. What we don't know over here is this distance is that distance right there, right? And let's keep in mind that's still the value of c in Pythagorean's theorem, okay? So here's what we've got. It becomes this. This little value down here is a. That little value right there is b. And that value up there is going to be c. So when I put it all together, I have this now. 7 squared plus 5 squared is equal to, and now I'm going to replace the c with x squared. X is actually the distance in between the 2 points that we have. So this is what we know. I got 49 plus 25 is equal to x squared. Now when I actually go about doing this this addition right here, we end up with 74 is equal to x squared. Now again, most of the time, guys, that you guys go about doing setting up the radicals and whatnot that you have, we have to use simplified radical form. Why? Well, in order to get the x by itself, I've got to take the square root of both sides. In this particular case, however, the square root of 74 will not break down. So the actual value of x that you would write in simplified radical form would be the square root of 74. Okay. The other thing that you need to know, it just depends on what the situation is, because if you've got some real-life word problems and you're talking about a distance to somebody's house or something, then you would have to be able to take this, the square root of 74, and put it into decimal form. And in this case, it actually becomes roughly 8.6. So here's another one that I want to get for you and try to trick you a little bit is what's taking place here. And the reason I'm doing that is because I want you to see that there are actually some faster ways to go about doing a few things than maybe what you're accustomed to, or maybe definitely than what I just showed you on the last particular one. So here we go again. I'm going to make my x-axis go about right here, like that. And I will make my y-axis now set it up over here a little bit more. And that ought to be plenty right there. Now the 2 points that we're going to use on this one are actually -4 and -7. So let's write those down. -4 and -7. And the other point that we're going to use is -4, 4. -4, 4. So again, let's go ahead and plot those points right there. Let's use Pythagorean theorem. Here we go. -4, -7. It goes 1, 2, 3, 4 to the left, and 1, 2, 3, 4, 5, 6, 7. Got it way down there. There's the first point right there. Second point is -4, 4. So 1, 2, 3, 4. And then I got to go up 4. 1, 2, 3, 4. Now here's what I hope that you're seeing right away. Can you create a triangle? The last time I looked, triangles kind of had angles. That's why there's 3 of them, right? And they kind of got a shape like that. Well, you can plainly see on this particular problem that this guy is actually straight up and down, where the points are directly above each other, right? And so because of that, there's no need to draw a triangle. No need to draw a triangle because that guy goes straight down just like that right there. Now what we have to do is count the spaces. So the distance between this guy is actually 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. The distance between them is 11 in this case. Same thing is going to work out when the points are horizontal of each other. Okay, so again, how are we going to use it? We're going to have our graph. You plot the points on the graph, and then we need to draw a triangle in there. And when we draw that triangle, then all we have to do is label the sides, and we can go about the business of using Pythagorean theorem to find the distance between 2 points on the graph.